Hello and welcome to this tutorial on live digital forensic response using KAPE, the crawl artifact parser and extractor. KAPE is a powerful free tool created by Eric Zimmerman, a former FBI forensic examiner. It's designed to efficiently collect and process forensically valuable artifacts from Windows systems, essential for live response. We'll follow the playbook step by step to download, configure, install, and use KAPE. Step 1. Go to the KAPE website, click on Download KAPE, fill in this mini survey, and select the Download Now button. Once you've done that, you'll get an email with the download link. Once you've done that, time to set up your storage media that you'll run and hold KAPE in. My recommendation is to empty out a USB drive. They are not expensive. Make sure that you have at least 64 gigabytes. Format it to a type that is usable on all systems, preferably exFAT, and create your 3 starting folders. KAPE, which will have all the files for the KAPE program. Evidence, where you'll store all the output from targets and modules from KAPE. And documentation, where you will write and hold the reports for the systems that you analyze. Once done, you can go ahead and extract the contents of your KAPE download into the KAPE file. Next, open PowerShell as administrator by right-clicking on PowerShell in the Start menu. Navigate to your KAPE folder with the command cd your drive letter /KAPE. And once there, run the KAPE update.ps1 script to ensure that you're in the current version. After that, run ./kape.exe/last_sync to get from the repository the latest modules and targets, which are constantly being updated by Eric Zimmerman and the community. KAPE doesn't bundle all the executables for its modules with its initial installation. You will have to do this manually, identifying missing tools by running ./kape.exe-mlist.-mdetail to see what binaries you need, and you can download them manually. For a basic recommended version of KAPE, there is also an automatic script to download the necessary executables designed by the community, the KAPE/EasyTools ancillary updater.ps1, that by dragging to our KAPE directory and running will automatically do some of the basic work for us, including downloading Zimmerman's tools. This is a great starting point, but we will go into a little bit more depth in our tutorial. This takes about 5 minutes to run and does a decent job of creating a baseline. A couple of the tools we need aren't transferred, so we will then go ahead and manually download Zimmerman's tools by going to the folder in the modules section of the KAPE directory and running the script that get Zimmerman's tools.ps1. This will download all the tools into that specific directory, and you can then move what's inside the directory into the bin folder, replacing what already exists and adding the extra tools. Next up, we want to download the tool we need to get the memory dump. We will do this with winpmem, which we'll download from the site, put in the bin folder, and rename as winpmem. For the computer that you'll do the digital forensics on, the analysis after you do the live response, you should download and ensure that you have installed the 9.0 .NET Runtime, the Desktop Apps Edition. Another very useful tool we will need is Hayabusa, that will create event timelines. You can download Hayabusa from the latest release and unzip the whole folder into your bin file, and rename the executable for your platform, which must probably be Windows 64, into hayabusa.exe. We want to download some of the tools from live.sysinternals.com, which are a series of very useful Windows-based executables. Specifically, we want pslist, psservice, psloggedon, handle.exe, and autorunsk.exe. Download them and put them in the bin folder. Finally, there are two scripts we'll need, which we have provided the links for. One is getinjectedthread.ps1, the other one is getNetworkConnection.ps1. Either download them through the browser and move to the bin folder, or directly from the bin folder you can run curl commands to get the raw data from the repositories and transfer them directly to the file. Alright, next up, actually running KAPE Live Response. We are in a Windows 11 VM that we will collect the necessary information from and run a series of modules to show you a live response. The file you're looking at right now is an actual piece of malware downloaded in order to have something to show. First things first, we want to launch KAPE's GUI. We will navigate to our KAPE directory, run gkape as administrator, and the gkape interface will appear with two main sections: the target collection on the left and the module processing options on the right. First things first, our first priority, the memory capture. We'll do this by using a single module, the Velocidex WinPmem. Our module source will be the C drive, but in actuality, it doesn't matter for this particular choice because we are getting a snapshot of the RAM. To organize all of our captured data, we should create a folder in the evidence directory, calling our case what it is, and then creating folders for each of our captures. A classic naming convention is naming the target output astout and the module output as mout. And inside, you can create folders according to your needs. Destination to your file of choice, which in my case I named memdump. Choose the module you want to use, which is the Velocidex WinPmem. And execute when ready. When finished, you can open up your chosen directory and see that the RAM has been saved to be used with any manner of programs afterwards. Another quick first step for live response action is to pick and choose a few basic modules that will get some information about the system and its connections. And you can do that by selecting the live response process details, network activity, and PowerShell live response system info. And now on to the main collection, which will take longer, but now that we have captured the RAM, means that we can take our time and collect more information. We will combine using the use target option side and the use module option side. You'll notice that the module source side is not red anymore, as the module will immediately use the output of the target side. On the target side, we will use the basic collection, sense triage, evidence of execution, and KAPE triage. For a faster version, you can just use the KAPE triage as suggested by the official tutorial of KAPE. But this way we get a little bit more, and by selecting deduplicate, we won't get multiple copies of the same files. We should also select process VSCs, virtual shadow copies, and ensure on the module side we have selected CSVs and that we have debug messages just in case something doesn't work as we wanted it to. We create a folder and select the comprehensive list of options which can be added or subtracted depending on the use case, but this will take full advantage of the executables that we downloaded earlier, and the list is sysinternals ps logged on, exclamation point easy parser, which is the main suggested module, Hayabusa, which will create an event timeline, live response net system info, live response network details, live response process details, mftecmd, network activity, persistence, recmd all batch files, and system information. It's quite a list and it'll take a long time to complete, but it is worth it for the complete picture. And execute. This took about 10 minutes, and once done, we can exit out from the KAPE application and take a look at our files. They've been exported as much as possible as CSVs, and it's the perfect format in order to use other programs such as the Timeline Explorer to visually and easily analyze and search through this humongous amount of logs. We can also see that on the target side, our collection has gathered most, if not all, pertinent files, registries, logs from our system that we can take and analyze on our own device in our own time to get a complete picture. So back on our system, it's time for the final step to analyze manually all the information that we have gathered using one of the Zinnerman's tools again, the Timeline Explorer. You will find it in the modules bin Timeline Explorer file. If you don't find it there, it means that you haven't downloaded and installed Zimmerman's tools correctly, and you can go back to that step and redo it. Once inside, a couple of settings you should fix. First of all, in the tools, at the datetime format, add 7 Fs in the end in order to have the seconds, tens of seconds timestamp to separate the timeline of events. Next up, on your evidence folder, navigate to where you have gotten all of your modules saved, and from there select those that are the most interesting to you. there is a suggested list given to you. For example, the evtx ecmd/output is the parsed Windows event logs that contain system activities, security audits, and application events. Automatic destinations is the jump list data showing recent files accessed through taskbar applications. The user activity is the activity history showing recently used files and applications. The anti-user CSV is the user registry hive containing personal settings and activity history. USR class, user specific registry hive file with file associations and shell extensions. The MFT ECMD MFT output is the parsed master file table containing metadata for all files on the NTFS volume, and so on and so forth. It's worth seeing what each of these are to understand what they say, as somewhere in this large amount of organized information is the data for the digital forensics process that you seek. The only thing left is to import all of these into Timeline Explorer, as you are seeing now on screen, and start going through them using the simple but powerful utilities of the Timeline Explorer, which I will demonstrate, mostly the find function and the organize function. And from now on, it's an observation and experience game in which you go through the most important file lists, find things that seem out of the ordinary, start searching for them, and piece together a relative timeline. And that's it. Thank you for your attention, and I hope this tutorial was useful to you. Happy hunting!